Hello everyone, so we are stuck on a rainy day and going to do a quick video on kind of a cash analogy, starting to put together an explanation of how Bitcoin transactions work under the hood, right? So we've talked a lot about blockchain in general in the previous videos, and a lot of that content is just about any implementation of blockchain, right? And all the stuff about headers and Merkle roots and hashes and previous previous block pointers is all blockchain stuff. This is, I guess, quite Bitcoin specific and quite cryptocurrency specific. This is how the actual transactions work, and I'm just going to start with a short video today, which will lead into a next video showing how this works in terms of the actual, the actual Bitcoin transaction inputs and outputs on the blockchain. But I want to start again with an analogy which hopefully will get you thinking in the right way about how Bitcoin transactions are sort of created and tracked on the blockchain. Okay? Makes sense? So I hope this video will be quite logical and quite simple. Stop me if so. By the way, I'm joined again by Ladisha, who's been diligently watching all the videos so far, right? But I guess you haven't been able to actually join them all, but I think you're kind of up to speed so far. So if you have any questions, then stop me, right? And also, guys, if you have any questions yourselves, please leave them down below, and I promise I'll get back to you quickly. So I'm just going to start by telling a little story again, right? And this is the real world, and it's a very simple scenario where we've got a bunch of people involved in our story. Okay, we've got Lance the laundrette. Okay, right. So he's running a little laundry business. We've got Bob in our story, and Greg, his twin brother, and we've got Chris, the coffee maker, or the coffee shop guy, right? And we're just going to talk about a couple of very simple scenarios of cash changing hands between these different people, right? So simple scenario, say 5 different steps of the story. First one is that Lance starts out with no money in the till, okay? And somebody, let's say on the first day that Lance opens for business, right? Somebody comes in and pays him a £5 note in exchange for a £5 dry cleaning bill, right? So at that point his till contains £5, and there's no change given, and that's fine, right? We don't care about who this person is at this point, because obviously, as we all know, cash goes all the way back to when it was printed and issued by the bank. So let's just say we're cutting the chain off at this point and saying somebody had a £5 note in their pocket and paid Lance £5 for some dry cleaning, right? Then on the same day, so Dad over here, he pays £20, right, in form of £20 notes to his twin sons, Greg and Bob, right? So Greg gets a £20 note and Bob gets a £20 note, right? And each of them have empty pockets at the beginning of the day as well, right? And so Dad has basically paid each of his twin sons £20, and then as soon as he gets this £20, Bob gets all excited and decides to go and spend it on some laundry, right? So he goes to Lance the laundrette,
right?
And he hands over that £20 that he received from his dad for his birthday. He hands it over to Lance and gets £5 in return, right? £5 change, because it was a £15 bill, right? Then Bob decides to go and celebrate his birthday by going to the coffee shop, right, where he buys a £4 coffee, okay? And he hands over that same £5 note that he received as change from Lance the laundrette, and he hands it over to Chris, the guy at the coffee shop, who gives him a £1 coin in change. And then at that point, Bob walks out of the coffee shop with £1 in his pocket. So Bob started the day with nothing in his pocket. And then at various times in the day, he had a £20 for a while, then he had a £5 for a while, but because of the transactions he was involved in, he ends the day with £1 in his pocket. Yeah? Makes sense? But you can see, so that £5 note that was paid to the laundrette at the beginning was given to Bob as change, right? Which was then handed over to the to the coffee shop. So you can see, and we all know this is how real coins and notes circulate around society. Right? We all know this, I guess, deep down. So if we say we're going to actually start capturing the details of these transactions in a very, very simple format, right? We're going to capture them in terms of inputs down the left hand side and outputs down the right hand side. So for each of these transactions, each time one actor in the system, each time they hand money over to the other party, we're gonna call that a transaction, right? Okay. And so if I show you here, so basically if we just enable these first transactions. So we're saying, so transfer A or transaction A, whatever you want to call it. Let's say transfer, because this is a transfer of cash from some random person to Lance. So transfer A was basically was that £5 being handed over. The output. So for each transfer, the input is basically referring to a previous transfer in the past that was responsible for that money being in the hands of the payer, so that he could pay the beneficiary. Right. In this case, we said we don't know anything about the payer, so we'll just leave that blank for the time being. Right. But the output is basically, we're saying for each of these transfers, who was the beneficiary? Lance in this case, and what was the amount? Right. And effectively, what was the actual thing handed over? In this case, it was a £5 note. Right. And then in the event that on one particular transfer, so if we actually look to the second transfer, which is the father on the same day giving the £20 notes to his two twin sons, right? Again, we don't know where the father got that got those two £20 notes from. We don't care, right? If we look far back in time, over here in the past, that we would, that there are some transactions that that have put this money in the hands of the dad, right? But for the time being, we just ignore it, right? Because we're just taking it from this point onwards and showing the subsequent transactions, the relationship between the inputs of those and the outputs of those, right? So, but we're saying transfer B there were two outputs of that transaction, right? They're listed number 1 and number 2. Number 1 output was that Greg, right, received a £20 note, and the second one was that Bob received a £20 note, right? And that's transfer B, right? So then, if we go to this scenario here, this is where Bob takes that £20 note and he went to the laundrette, right? And he handed over the £20 note, got £5 change. So that's a transfer in two directions. The first one is Bob paying the laundrette, £20, and then the second transfer is the laundrette paying Bob the change, right? So in this case, transfer C was basically Bob handing over £20 to Lance the laundrette. So this is the interesting part. So you can see the inputs to this transaction are what enables Bob to hand over the £20 note to Lance. Well, it's the output of transaction B, right? And you can see the line of dependency there. It basically says so output number 2 of transaction B is payable to Bob. That's what enables Bob to pay a £20 note to Lance.
Right.
Yeah? So in the inputs, you reference the outputs of previous transactions that enable you as the payer of this transfer to pay the payee what you're paying them.
Right.
Yeah. And exactly the same in terms of the change. So we're saying this transfer D is the payment from Lance the laundrette back to Bob of £5 change.
Yeah.
And that references output number 1 of transaction A. If we go back to transaction A or transfer A, and output number 1, which is this one here, we see that this one said Lance receives £5 note, right? And that is what enables Lance to pay Bob a £5 note in change.
Right.
Right. So then, does it make sense so far?
Yeah.
So we've just got these transaction documents so far that list inputs and outputs, and then there's a relationship between outputs of one transaction to inputs of one transaction to outputs of previous transactions. Yeah. Then we have our scenario where Bob goes to the cafe, right? And now we say, so Bob hands over £5 note to the cafe to buy this £4 coffee.
Yeah.
He references, so basically the output that was responsible for putting that £5 note in Bob's hand was transaction D, output number 1, which was Bob receiving £5 change from the laundrette. So we reference that output and say basically this output allows us to pay Chris the same £5 note.
Right.
Yeah. And then in return, again, this is the change, transfer E, is Chris, the cafetier, whatever, he's paying Bob £1 coin in return. And we just put a question mark here because we haven't included the transaction that explains how Chris got this £1. But it's somewhere there in history, right?
Yeah.
It's just we've chosen to ignore it, just like we chose to ignore this one and this one.
Yeah.
Does it make sense so far?
Yeah.
So really, the reason I'm talking about this is because this is exactly how Bitcoin transactions work, and Bitcoin really is digital cash. It's far more closely related to cash than it is to, let's say, electronic banking as we think of it, where people have an account balance in a bank and they they withdraw money. It's actually far more analogous to a cash transaction. And in future videos, I'm going to go into exactly how this cash concept extends to the transaction document in a Bitcoin transaction. But for now, I want to sort of really get the point across that these transaction documents here, right, are what gets stored in the actual Bitcoin blockchain, right?
Okay.
So the Bitcoin blockchain is really nothing more than a secure and distributed list of all of these transactions that have ever happened, right?
Yeah.
Make
A
sense?
ledger.
It's a ledger, yeah, exactly. Yeah. So if I just fade this in, like this. So think of it like this, right? Think of it like, imagine every time one of these exchanges of money, of cash, happens between any of these parties, right?
Yeah.
Imagine each time that happens, somebody fills in like a little pink slip,
Yeah.
right, on a piece of paper with inputs on the left. First of all, he assigns a unique identifier
Yeah.
for that transaction, right? Maybe a random number, or it has to be a unique identifier. Again, I don't want to get too bogged down in the analogy, but it has to be a unique identifier. Fills out a pink slip with the inputs and outputs, right? And just like in the format, it's exactly this, right? So the inputs refer to the unique identifier of the transaction whose output you're referring to spend it, right? And so literally just a pink slip with this information on it. And then if you see my previous videos on the the blockchain being the stack of boxes and the scales and all that kind of stuff, then it ties in neatly with that. So you basically take all these transactions as you hear about them, right? And you basically just store them in these boxes, right?
Yeah.
And then every couple of weeks, basically, you what happens is that these boxes get sealed. You've seen my previous video on the whole blockchain side of things, but effectively what you end up with is a big stack of boxes containing pink slips detailing every single cash transaction that's gone on in the real world, right?
Yeah.
This is just cash, it's just coins, it's just notes, right? And that's your blockchain. So these are your Bitcoin transactions, or let's say these are your cash transactions. They are documented in this format, and then they're stored in the blockchain in a secure way that can never be altered, etc., etc. So we just take for granted that the blockchain takes care of the fact that once these transactions are stored in here, they can never be altered and they can never be tampered with, they can never be removed, and all that kind of stuff, right? So I think we're kind of making progress. Now the next part of it is really about, if I just zoom out for a second. So one key question that we want to know the answer to is, how much cash is Bob holding at any point in time? You've asked questions about this in the past, right? In terms of, how do we know, just from this list of transactions, how much cash Bob is carrying around in his pocket right now, right? We know that right now Bob has not used this £1 in any subsequent transactions, right? And we know that by looking in this box and pulling out all these transactions here, and basically we can see that you can see that this £1 output has not been spent yet, and I'll go into exactly how that happens. But how do we know, just from looking at these transactions that we have in the box, how much any of these guys, how much cash any of them are holding, right? But let's take Bob as a simple example, right? So if we, first of all, so we want to know how much cash Bob has. If we look at all the transfer documents inside the boxes, right, and that's our blockchain, right? Now, the next thing we do is we find the outputs where Bob is the beneficiary, right? So which transactions have paid Bob some money? Well, in green, right, we can see that transfer B, output number 2, paid Bob a £20 note.
Yeah.
That's fine. Transfer D, output number 1, paid Bob a £5 note.
Yeah.
And transfer F, which was in the coffee shop where Bob got his change, paid Bob a £1 coin. Right. So those are all the instances where Bob has received cash, right? Assuming that he started from zero, right, before these transactions. Yeah. So we know all the outputs where Bob is a beneficiary. But the next thing we have to do is we have to remove the transactions that are referenced as inputs to other transfers, right?
Yeah.
And we can see exactly what we mean by that, because we see that in transfer C, we said that the input to that transaction, right, was Bob basically was paying the laundrette that £20 note, and he was referencing output number 2 of transfer B, which is when he received that £20 note. So transfer C basically proves that Bob has actually handed over that £20 note, so he no longer has it.
Yep.
Right? So B number 2 is out, and then also, so remove the ones that reference as input to other transactions. So D, if you look at D, transaction D was where Bob handed over that £5 note to Chris, and he was referring to transfer D, output number 1, which was when he received the £5 change from the laundrette. So transfer D, number 1, has also been used as a reference. You can see it here. It's been referenced to pay for the coffee, right? So that proves that this one and this one have to be removed from here, right? Because they've already been used up.
Yep.
Right? Make sense?
Yep.
So then you can see that. So that what we then do, right, is let's just name these things, and because this is a very important term. Just move this up a second. This is a very, very important term in Bitcoin, right? So let's just get used to this term. Let's name. So the one remaining is F, number 1, right?
Yep.
So F is the only unspent transaction output. Let's call it UTXO. So if you just burn that into your brain, right, you hear it all the time. UTXO is unspent transaction output, right? So it's from all the transaction outputs that list you as the beneficiary, which of them have been unspent, as in which of them have not yet been used,
yep,
as inputs into subsequent transactions,
yep,
right? So if you see, so we took B, D, and F. So B output number 2, D output number 1, and F output number 1. Those were our transaction outputs. We removed the B and D ones because they've already been spent as inputs, right? And that leaves you with the unspent transaction output, right? Which is F. It's just F. F output number 1, which is the £1 coin. So we were able to deduce, just by looking at these transactions, that Bob is carrying exactly £1 coin with him.
Yeah.
Does that make sense?
Yeah.
So, and this is the power of blockchain. So nowhere in the Bitcoin system or on the blockchain will you ever see anything like, okay, Bob's balance is £1, right? Sorry, I know I'm talking about the Bitcoin blockchain network, and I know this is just a physical analogy, but nowhere in
But you're trying to say that it's not stored anywhere.
Yeah, exactly. The balance is not stored anywhere. The only thing that's stored is transactions, right? You can derive, as we've just done, I can derive that based on this transaction history, Bob's outstanding unspent balance is £1, right? And £1 only, because all the other transactions that he was a beneficiary of, like the £20 here, the £5 here, have already been handed over in other transactions.
Yeah.
And you see that from the inputs of other transactions,
Right.
But I can see on the fly that Bob is holding a balance of £1, right? And the point is, because this blockchain, because this transaction list is duplicated and robust to interference, then we can be sure that we can look anywhere on the network. Or let's say we can always look in this box and find out what each person's balance is. But it's just a number that's derived on the fly, because the only thing that's in the box is the transaction. Like these could be like pink slips, right? So, in the box. So
well, I think it would be good to understand how this applies in the real world, because from what you're saying, everybody can look up what each person owns in Bitcoin. So how does this work in the real world?
So how does it work in the real world in Bitcoin or in
Bitcoin? In
Bitcoin. Yeah. Well, I think so. What I'll do, just to keep things reasonably succinct, is in the next video we'll actually go on from this in detail and say, right, well, we're going to look at the blockchain.info website and see some sample transactions, and we'll see how Bitcoin transactions actually have inputs and they have outputs. In fact, I'll just show you very quickly so you can see. So I won't go, just to kind of lead into the next video. So here we are back at blockchain.info, which we seem to end up on in most videos, and this is basically your your transaction format of a Bitcoin transaction, and it's exactly the same as what we've just seen in the real world cash side of things, where you've got inputs listed down the left and outputs listed on the right. And so in here, I'm not going to go into too much detail, but just to give you a taster, you've got the amount that you're paying each of these beneficiaries in the transaction, along with their Bitcoin address, which is basically the equivalent of their name, like Lance and Bob, etc. And on the left, you've got the actual the inputs, which are references to previous transactions,
Yep.
proving that you have the wherewithal to actually generate a transaction with these outputs, right? So if you see on the input side down here, these are the outputs from previous transactions that this person here, right? The instigator of this transaction.
Yeah.
Well, no, the instigator, the payer of this transaction,
Right.
has referenced these outputs
Right.
to pay these beneficiaries this amount of Bitcoin. If you click on any one of these outputs, you'll see that it's basically, it takes you to the transaction,
Right.
and then each transaction in turn has its own inputs and outputs, and he's referring to one of these outputs.
Yeah.
Right?
Yeah.
So we'll go into more detail about how it works in the next video, but
Okay.
just to give you an idea, it's that concept of having inputs down the left, outputs down the right. The input section is referring to outputs of previous transactions, showing you that you are basically, you're the beneficiary of a previous transaction, which enables you to instigate a new transaction and transfer value that way.
Right.
So does that kind of make sense? I think
Yeah.
it's really, really important to sort of bring in the idea of sort of cash in your pocket. At the end of the day, a Bitcoin wallet is something like a manager of all the coins and notes in your pocket.
Yeah.
That will tell you, first of all, on the fly, okay, what's my current balance? So what's the total amount of Bitcoin I can spend? But it will also, it's responsible for creating new transactions when you actually want to spend Bitcoin,
Yeah.
and deciding which previous transaction outputs you're going to reference,
I think, yeah.
right? Which is just like when you go to the supermarket and you pick out all the coins in your pocket, right? And say, okay, I've got to make £2.37 out of all this. You're looking at all of these coins that you've received from previous transactions and saying, okay, which coins does it make sense to use? So your Bitcoin wallet does all that sort of similar stuff there. But yeah, we'll go into
I think it would
more
be better
detail.
if you-
Yeah, we'll do a separate video on that. But okay, so does it make sense?
Yeah.
So I just want to leave you guys with one parting thought, which I think is going to lead very usefully into the next video. So we've talked in this video about the idea of these documents, these little pink slips, being written up to record the cash transactions that are going on in the real world, and then those pink slips being deposited in a box here for safekeeping, so that anybody can go in and see what value's been changing hands, and find out how much cash each person would be carrying at one point in time. But I want to sort of leave you with something to think about, which is, as the beneficiary of each transaction gets listed as the name and the amount of cash that's paid to that beneficiary or that payee, okay, their ability to actually spend that output in subsequent transactions, the evidence of them being an actual beneficiary of that transaction manifests itself in the fact that they are actually physically carrying around that amount of cash in their pocket. So for example, Bob down here was the beneficiary in transfer F of £1 coin in change from the cafe, and Bob, as a result, is carrying £1 in his pocket, and that is, in the real world, that is what enables him to go and spend that £1 somewhere else. Okay, that's how he effectively proves to the world that he is the beneficiary of that transaction, because he actually he carries the physical money, and that's what enables him to go and then spend that pound. Obviously, you can't spend the pound unless you have the pound. I want to just open up the idea of what if there's a way to say, well, as the beneficiary of this transaction here, right? If there was a way to ensure that Bob, instead of actually handing over a £1 coin, he was just able to effectively create a new transaction document and sign that document in a way that only he can. So basically, if he could prove in a subsequent transaction, if he could prove that he was the beneficiary of transfer F by somehow signing this transaction down here, then you could actually do away with the coins altogether. And you could say, actually, we don't need to carry coins and notes around. We can actually just use these documents as transfers of value, right? And I can say, so if transfer F pays Bob in such a way that only Bob can sign a new transaction that refers to the output there, right? Just in the same way. And Bob was able to basically say, right, I'm creating a new transaction, and it pays, let's say, Lance, £1, right? And I'm using as that, I'm using the output from transfer E, but rather than actually needing to actually transfer any physical cash, if there was a way for Bob to prove by signing this transaction that he was the only person able to spend that output, then you actually wouldn't necessarily, or wouldn't at all, need this physical objects changing hands. You could do it all just using these pink slips. So in that way, you can conduct business just using transactions without using money at all. So each time, so for example, so we're using these pink slips earlier in the video to actually record and just basically document the exchange of cash. But if we were to sort of turn it on its head and say the pink slips themselves are the means by which the value is transferred, the only challenge is if for example this transaction here says, okay, pay Bob, we need a way to make sure that only Bob can transfer that output to another output, let's say Lance, in subsequent transactions, which would mean we need a way to somehow make sure that Bob can somehow sign the new transaction and that only he can do it, right? So if that's, I really just want to sort of open your idea, open up the idea of that concept, because that really is, I guess, it's the last piece in the jigsaw in terms of the, let's say, building the bridge between cash transactions, like we've discussed here, and then inputs and outputs and the dependency of between transactions in time, and then effectively what really happens in Bitcoin, because Bitcoin is really just a sequence of interconnected transactions between inputs and outputs, where the recipient of one transaction signs subsequent transactions in a way that only they can, and transfers the money like that without actually changing, without there being any actual objects that change hands. Right. So if that's not clear, I think it will be clear in subsequent videos. If you want to leave any questions, I'm more than happy to answer them. So thank you very much for watching, and I'll see you in the next video.